So good morning to all of you. So already instrumentation control system, we discussed about that introduction part, as well as we discussed in the previous, that means the last month 15th to 18th, that means 4 days classes, right? So in those classes we discussed about the uh, introduction of total overall the course, and the difference between instrumentation and instrument. And also we discussed about the instrument performance characteristics. Those are static characteristics and dynamic characteristics. And the next, another one more we discussed. That is what is classification of static characteristics of an instrument, a physical parameter, and also discussed about the range and span. Range and span. So these are the topics we discussed in the previous class. Now we are going to discussing about uh, here methods of measurement and static characteristics. Today, that means today after completion of the class, you can acquire knowledge so regarding these methods of measurement and static characteristics, right? The static characteristics uh, I already written on the board, right? What are the static characteristics of a measuring instrument? So those are the performance of the here methods of measurement. Two methods are there. One is a direct method, and another one is indirect. See, before that, we have to know measurement. Already, this is discussed. Already discussed. We discussed about the system, measurement system, and uh, what about that? If there is any controlling, so device. It's a device system and a measurement system. And then, if you observe here the measurement, the input, the other words of the input is also, we can also call as measuring. Remember this point. Input here, this in this, see here, uh, input. Input is also called as measuring. That means here the input, whatever the measuring, that is nothing but the result. You can get the result. Result we can also call as a readout. Here in between this one, here some process of comparison, comparison that is called a measurement. So this comparison is with standard one. This comparison with standard one. So this is the measuring process. This is the fundamental of measuring process. Always the input we can also call as input signal. We can also call as measuring to a measurement system. Here a measurement system is there, right? Here input is nothing but signal, that is nothing but, in other words, measuring. The output, we are getting the output signal, which is nothing but the measurement of a physical variable by comparison with the standard. Now you got the clear. Here the result, the output, this result we can also call it as output. The output, the other words, read. We can read the data from the monitor, or we can note down. So that is nothing but a parameter. That is a physical variable we can measure, that we can call as a measurement. So here, whatever the physical variable we are measuring with the help of an instrument is called a measurement. That is a measurement in the words of, see here we are comparison with the standard one. So this is the fundamental of measuring process, right? And the next. And direct methods. Here in these methods, the unknown quantity called the measure. Here, the unknown quantity. The unknown quantity we have to measure. Here, the unknown quantity is nothing but called the measurement. Measurement is nothing but input signal. Whatever the unknown quantity we are measuring, that is the output. See here, again, I'm repeating. See here, measurement, we are saying that it is unknown quantity. Measurement, it is nothing but unknown quantity. See here, unknown quantity is called, what is that unknown quantity is a measurement. That is the input. That means we can get the output is nothing but the measured value by comparison with the standard. Measured value. We have to measure. Here, for example, the unknown quantity, for example, say this cell phone, this is, say this is unknown quantity. The length is unknown quantity. I have to measure. What is the device here? A scale. With the help of the scale, I have to measure. So I have to measure the, what is the length? That is the measurement with the help of the standard. Here the scale already, it is a scale in such a way that divisions, maybe 15 centimeter or 12 centimeters. That is the standard one. With the help of the standard, we are measuring the length of the whatever the cell phone. Some disturbance is coming, right? Right. Then see here, I hope so you can understand. See here, again I'm repeating. See here, this is a cell phone, and I want to measure this length. This is unknown quantity, measure, that is the input. So that means here the measurement system is nothing but here the scale. I have to measure with the comparison with the standard one. Here the scale on division is the standard length. So I have to measure. Here the unknown quantity is nothing but measure, and the output is nothing but measured value against the compared against the standard. That is called direct method. We can that is directly we can measure the length. And then next to indirect method. Here some of the things here this is cell phone, right? The length we can measure directly. Some of the variables, physical variables, in such a way that we cannot measure directly with the standard measurement system. So for that, that is called indirect methods. The measurement by direct methods are not always possible. So that is not always possible. That in engineering applications, actually, the measurement systems are used which require a need of indirect method of measurement purposes. Means here in engineering applications, a wide range of engineering application in this we have to measure indirectly. There are so many applications out there. Further, we can discuss in instrumentation, total completely displacement measurement devices, level measurement devices, flow measurement devices. These are all the indirect methods. I will explain you in the coming units clearly. So here now, what is in direct measurements? We can measure directly by comparison with the standard. Right. Indirect method means all the measurements are not always possible with the direct. Right. Engineering, wide range of engineering applications, indirect methods or more for measuring a physical variable or a physical. So these are static character, classification of static characters. See here, desirable and undesirable, desirable and undesirable. See here in the desirable, accuracy, sensitivity, reproducibility. See here, here accuracy, sensitivity, reproducibility. In undesirable, drift, dead zone, static error. And in the dead zone, threshold, hysteresis, resolution. So now I will explain you one by one. I will explain you one by one. I will explain you one by one. Right. And the next two, we'll go for the next two. So now here, this is the, see here, static characteristics, right? for instruments and measurement systems. So these are accuracy, sensitivity, reproducibility, desirable and undesirable. I will explain you one by one. Accuracy. What is accuracy here? Accuracy means it is the closeness with an instrument with the true value. Here, one instrument, we are measuring a physical variable. That variable, which is very close to the true value, then we can say the instrument is very accurate. Right? For example, with the help of the thermometer, I measured in this particular room. So maybe room temperature, it should be around 28 or 29 with the help of the thermometer. And with the help of the device, instrument, another instrument which is displayed, if I place over here, it it will be whatever the variable, that is the temperature, it should be equal to that what I measured with the help of the thermometer. Then we can say the instrument is more accurate. So for temperature measurement instruments, there are thermocouple is there, thermistor is there, RTD, resistance temperature detector. There are so many elements or sensors or transducers are there to measure the temperature. So accuracy means whatever from the instrument we can get the physical variable, that physical variable which is very close to the true value. So then we can say it is accuracy. So what is the true value here? What is the true value? So are you getting my voice? Are you getting? Anybody can post a message in the chat box. So if there is a, if you are feeling any disturbance, so you can drop. I can see, so I will make it correct. So right, okay, right, good, Mister. Number 313, good, right. And lateral into 301. 301, it's not clear. It's not clear. 301, lateral entry. Clear or not clear? 301. 301. Lateral into 301. Voice is not clear. And 307, your voice is not clear. No? So maybe now 301. Speak out. Now it is clear. 307. 307 now clear. Okay. 301. Okay. So now, so here the true value means here the true value here the pin is not probably it is not fitted correctly. So that's why. True value. The true value of quantity may be defined as the average of infinite number of measured value. That means already the true value, it is nothing but a standard one. It should be defined as the average or infinite. That means the average of measured value is nothing but so many times measured value. That is nothing but the true value. For example, in this room, I got 27.8 temperature, and then 27.7, 27.8, 27.9, like this, which is a very nearer all the things, 27 or 27.9. The average of all the things is nothing but the it's true value. And then, for example, and sensitivity. Already the sensitivity is also explained clearly. Sensitivity is nothing but it is the ratio of what is that change in the output signal to the change in the input signal. Uh, that is sensitivity. Sensitivity is nothing but what is sensitivity? Here you can say the instrument is very sensitive, right? Here, if you go for the input, see here. The input is on x-axis, right, and output is on y-axis, right. Here it should be the sensitivity should be the curve is a linear. That means input is proportional to the output. So sensitivity is nothing but change in the output signal, ratio of the change in the output signal to the change in the input signal. Sensitivity. Next, we'll go for the next one. Next slide. Reproducibility. See here in this, so we discussed accuracy, sensitivity. Accuracy, what is accuracy here? The accuracy means it is the closeness, which is closeness to the true value. That is the measurement, whatever the measurement physical variable, that it should be close to the true value. And sensitivity means that it is the ratio of the change in the output or the magnitude of the output to the magnitude of the input. And the reproducibility, next we are discussing about the reproducibility. I will ask one by one. Lastly, you have to listen carefully. I will ask one by one. Reproducibility means it is defined as the degree of closeness with a particular reading of an instrument take at different times repeats itself. Reproducibility determines the precision of the instrument. That means here what is the here the reproducibility means, all of you listen carefully. If you listen means then it's you can get a good idea. Reproduce. See here, for example, here take the temperature in this particular room. I measured. So here I got the temperature 29.8 degrees centigrade. And after same experiment I did after some time, or otherwise, so same, for example, in the morning 10 o'clock I measured the temperature of my body. For example, take my body temperature 10 o'clock, it should be 98. And 11 o'clock also it should be 98, and 12 o'clock also it should be 98. That means at several times, that means take a different times, that means see here, different times repeats itself. That means you can get close to the, that value should be close, very close. At any time, if I performance experiment, whatever the reading I got, the physical variable, that should be same. If I repeat several times, that is called reproducibility. For example, I want to measure my body temperature, then with the help of the thermometer, at 10 o'clock I measured, I got 98.2, and 11 o'clock 98.2, like that. So that is nothing but maybe 98.1 sometimes. So that should be, the temperature should be several times, which is close to that value. For example, 98.2, 98.1, 98.2, 98.3, like that. Several times, that is called reproducibility. So this reproducibility determines the precision of the instrument. Here, sometimes you can say the instrument is a very, very precise. Precise means that the reading is accurate. Accurate, and it is also which is close to the true value. Now I will tell you the difference between the precision and accuracy. Okay, now you can get the clear idea. Precision, see here, the precision, it refers to the degree of agreement within a group of measurement. It prescribes the ability of the instrument to reproduce its reading over and over and for a constant frequency. That means if you give, for example, fan is rotating, right? I switch on the fan, I regulated a second or third, and I find the speed in terms of RPM, right? Several times, at any time I did what I can get same RPM, right? If same RPM, then we can get, then we can say it is a precise instrument and a precise element. Are you understanding my anybody having doubts? Here, what I said, reproducibility is nothing but it determines the precision of an instrument. For example, I switch on the fan and then it is regulated in 3 or 2. So now I measured the speed of the rotating fan speed. That means in terms of revolutions per minute. So, for example, 3 or 4 times I experimented, and then I can get the same values. Then it is a somebody said that once again explain precision. Now, okay, right, clear, absolute right, Mr. 26 K per 1. I will explain you with a graph clearly so that you can understand the what is a precision clearly. Precision means now. Anyway, I will take the example now. So now here, Pawan, listen clearly. I switch here. I want to measure the speed of the fan in terms of RPM. Example, fan, our fan, or whose house appliance fan. I switch on the fan, right? So the regulator is in 3, regulating that. So here in the mode of 3. So now I measured the speed of the fan in terms of RPM. So I got some RPM, right? After some time also in that same mode, I can get the same value, right? Maybe somewhat very near at that RPM. Like that, like that 3 or 4 times, 5 times, if it is very nearer to that value, so all values are very nearer, then we can say the fan is very precise. Sir, somebody asked, sir, sir, is the precision and reproducibility and accuracy same? No, no, no. Reproducibility and precision both are okay. Here, reproducibility is nothing but it determines the precision of an instrument. Actually, reproducibility means at any time, at any environmental conditions, if you measure any physical variable, it should be same. It should be close. That is called reproducibility. Precision means any time that all the values should be very nearer, then we can say it is called a precision. No, no, there is a Telugu, I am not able to. Mr. 13, number 13. Number 13. No, only in English only, right? Now, Lavanya Reddy, you got my point? You got my point? Lavanya. Pavan? Pavan. Okay, Pavan, Pavan. Again, I'm repeating. Now you can, Pavan, number Pavan. Pavan, he said that I am not understand, sir. Pavanamma. Okay, right. Now see here, somebody said that now it is very somewhat typical. It's very confusion. I understand, but with the help of now the next slide, with the help of that, you can get a clear idea. It's 100% sure for that. I'm giving 100% for that. See here, it is the difference between accuracy and precision. Clearly, see here. See here, I perform one experiment on an instrument. So here I got, these are the readings. See here, these are the readings. See here, these are the readings. So these are the readings, several readings on one instrument. That is the physical variable. So these are these are the readings, right? These are the readings, right? So the average of all the readings is nothing but this is the value, this is the value, this is the average value, and this is the true value. Actually, this is the true value. This true value, the average value, is not nearer to the true value. Then we can say it is a low accuracy. Now you got the point. All of you listen carefully. So with the help of these graphs, you can get a clear knowledge on this accuracy and precision, right? So here, these are the readings. I performed experiments on one instrument and I got the readings. These are the readings. The average value of all these readings is nothing but this is the value, and this is the true value is the standard. Mr. True value is the sense means fixed value. Yes, right. True value is the standard one. So that's why before I told you the measurement system. True value, that means the input is compared with the standard. Standard one is nothing but the true value. Right? Right. So low accuracy. That means the average value is not nearer to the true value. Then we can say it is low accuracy. And low precision means here the readings are not close. You got the point. Now you got the point. The readings are not close to all the readings are not close or not nearer. So then we can say it is a low precision.
Now you got the point, right? In the second, so same instrument. Here the readings are very, very close. All the readings are very, very close. I performed experiment and I got the values from the instrument. And so all the variables are very nearer. See here in this experiment, all the readings are very near. Then I can say it is high precision, high precision, high precision. And the average value of all these readings, this is the average value, and which is not close to the true value, which is not close to the true value. Then who can say low accuracy, low accuracy. So now from this graph, here the last graph, if I see here, these are all the readings. So these are all the readings, several readings, which are very close. So I can say it is high precision, high precision. And the average value of all these readings is very close to the true value. Then I can say it is high accuracy. So now all members got the point, right? All members got the point, right? So the difference between accuracy and precision, right? So now all of you, okay, right? Thank you, thank you. So now you understand. Accuracy means here that whatever the readings we are getting, that readings, it should be the average value of all the readings should be very close to the true value. Then only you can say high accuracy. And high precision means all the readings should be very close to each other. Then we can say that it's a precision, precision. Correct? Now we got the clear. I hope so you got the point, right? High precision means, see, all of you listen carefully. One member asked for that high precision. High precision means, how can you say that high precision? See here in this here, uh, it is high precision, right? High precision means all the readings, see here, all the readings at any time you are measuring, which are very close to each other. All are very close. See, all the readings from a particular instruments we are measuring, that is all are very close to each other. Then we can say high precision. And if it is, if we like this, the different at here, it's not very close, then we can say it is low precision. And this is high precision. So now you got Sarath 356. You got the point, right? You got the point? High precision means at any time, if you perform an experiment, you can get the physical variables. So many at any time to time variation, all the physical variables are very nearer, whatever the measured variable, it's very nearer. Repeatability, I will explain. Repeatability means at any time, for example, watch is there, right? Repeatability, I will tell you. Repeatability and reproducibility is nothing but it determines the precision of the instrument. It determines the precision of the instrument, whereas repeatability means at any time, if you measure the variable, it should be same. It should be same. That is the thing. Number 312. Repeatability means at any time, for example, today at 10 o'clock, I measured the temperature. Tomorrow at 10 o'clock also, I measured with the same instrument, it should be same temperature. It should be, I got that. So that is the thing. The instrument, there is no change in the instrument. Due to environmental condition also, maybe the reading will be changed. If it not change, if it repeats the same variable, same without any change, then we can say it is a repeatability. Right, now it's clear. Next, I will go for the next one. Here, drift, this is undesirable. See here, we discussed accuracy completed, sensitivity completed, reproducibility. And the reproducibility determines the precision of an instrument. That is also we discussed. Now we are going to discussing about a drift, dead zone, and static error. Here, what is here? The don't talk. One member 322 lateral entry. Here, that means drift means I will clear. I will tell you clear. This drift is nothing but it denotes the change in the indicated reading of an instrument when the time changes. That means here drift means all of you listen carefully. Simple drift means what is it? Drift means here if there is a change in the input, there will be a output is also changes. Output is also changes. For example, take the daytime temperature in the morning. Temperature should be maybe 24, 23 early morning, and in the that means mid of the afternoon, that is mid, it should be around 32, 33. Again, evening it falls, and at night 9 o'clock or 10 o'clock, 12 o'clock, it should be around again falls. That means if the input, that means if whatever the input changes, automatically the output is also changed. That is the, or maybe sometimes, that is one thing, one condition drift. Another condition, the input is same, the output changes with respect to time. The simply you can remember this one. The input, whatever you are giving, the input is the same or constant, and then the output, the variable changes with respect to the change in the time, with respect to change in the time. So now you got the drift, right? Definition, drift. And the next, dead zone. So here, and then dead zone means, right? What is a dead zone? Even if you give input, there is no response in that particular instrument. That means we cannot get the output for some particular period of time. We can call it as a dead zone. Simply, we can call for an instrument or for an equipment. If you give input, there is no output. We can call it as a dead zone. Dead zone. That means when you switch on the fan, that means if I give input, the electric current, I am supplying electric current to the fan. See, the fan is not rotating. That is called dead zone. So I have to push the wings of the fan, then it will rotate. Now you can understand, right? Here the input, here dead zone means even though if you give a input signal, there is no response in the output. That is called dead zone. And static error means even this at the static error, simply even in the rest position also. For example, error means the reading should be, there is an error. For example, the temperature of the water. The water is in stagnant. The temperature of the water, right? So always, sometimes even though the temperature will not change, even it is a room temperature, we can get a small minor errors, maybe in terms of 0.0101 like that. That is small errors. Here, for any instrument, errors are there compulsory. That is referred with the reference of the standard. And then next here, if you see in this dead zone, in the dead zone, again the dead zone threshold is there, hysteresis is there, resolution. What are the three definitions? Three in the dead zones, three: threshold, hysteresis, and resolution. These are three we will discuss now. Right. Here, what are the three we have to discuss? Uh, Threshold, hysteresis, and resolution. Right. Here, hysteresis. See here, if you see in the hysteresis, static error explain. Okay, I will explain you. Here, I will explain you later now. Mr. Narendra 337. Here, this is the difference between a threshold. Here in the input, hysteresis means here if you give input, see here, this is the curve we are getting. Give input, this is the curve, right? For example, see here, for example, I want to go for performance of an engine. Already in our thermal engineering lab, it is there. So I weighted a 2 kg weight, next 4 kg weight, 2 kg weight, I got some reading, and 4 kg weight, I got some reading, and 6 kg weight, I got some reading. So in the reverse of that again, 6 kg, next 4 kg, 2 kg, the readings will not be the same what I get initially. So that is unloading. Again, this is unloading, right? This is unloading. See here, now you can understand what is hysteresis means. Here I added weight to, for example, I added weight to perform the, to determine the performance of an engine. 1 kg, 2 kg, 3 kg, 4 kg, 5 kg, like that. I increased. So that means that is the input. The load is increased. Obviously, you know very known. When the load is increased, automatically the speed of the engine, what happens? Speed of the engine decreases. So similarly same in the reverse way. Reverse, for example, take the speed of the engine parameter. 1 kg, 2 kg, 3 kg, 5 kg, 6 kg. I increased the load. So I got the speed of the engine in terms of RPM. So when I in the reverse order, that means 5 kg, 4 kg, 3, the speed of the RPM should not be the same what you get the initial. That is due to the internal friction, that is unloading. So that is called hysteresis effects. That is called hysteresis effects. And then if you come to the threshold, so now you got the point, hysteresis. What about hysteresis? You got the point, right? Hysteresis.
Hello.
You got the point, or you understand hysteresis? Now threshold. Here threshold, see, even if you give input some period, there is no output. The output is zero. The output is zero. After a certain period, when you increase the input with respect to time, then only there will be a change in the output. We can get the output, we can get the response from a system. You understand? Threshold. Threshold means even if you give input for some period, there is no output. So after that, if you give inputs here, see, even if you give input, there is no output here. Output is zero. There is no response in the system. So one minute. You understand here? Threshold means even if you give input, there is no response from the system. After that, after this, see here, after this, if you give input, there is a change in the output. Yes, dead zone means I said it to you clearly 2 times, right? So what is a dead zone here? Here dead zone means hysteresis is the part of the dead zone, but it has output how? Yes, correct. Dead zone means here, in other words, somebody say in the hysteresis also there is no output for starting input values. Yes, that means see here in this graph. See here, if you observe clearly, for some particular input is also there is no output we are getting. That means some period there is no response from the system. That we can call it as a dead zone. Dead zone, right? Mr. Number one, number 348, lateral entry, 348, 348, 348, 348, 348. You can understand. Okay. Here also see here for some particular period of input, there is no response in the system. After that, there will be a change in the output. నేను ఇందాక చెప్పాను కదా మనం ఏమని చెప్పాను, ఫ్యాన్ స్విచ్ చేస్తే తిరగదు. ఇంకా ఏంటంటే కొన్ని ఫర్ ఎగ్జాంపుల్ 120 volts అనుకో, ఫ్యాన్ అటు తిరుగుతుంది, తిరగదు. ఈవెన్ సమ్ ఆఫ్ ద ఫర్ ఎగ్జాంపుల్ ఏసీ అనుకోండి, ఫర్ ఎగ్జాంపుల్ మన ఎయిర్ కండిషన్ కూడా, if the supply voltage is 100 volts, 120 volts, it will not on కాదు. AC needs 240 volts compulsory. Then only it will be the compressor will on. So even 100 voltages or 120 volts, it will glow. So that period we can call it as a dead zone. That period. And if you go for resolution, the last point. Resolution means if you give very small change, small input, the output should be very, very large. That is called resolution. What is the resolution? Resolution means if you give input, very small input, the output should be a very, very large. The output should be very large. So don't forget it. Resolution is, again I'm repeating, the small change in the input, there will be a large output we are getting. That is called resolution. One side. Then why don't we call as a dead zone in threshold? No, here a dead zone, in the dead zone, 3 types are there. One is threshold, hysteresis, and resolution. Even what I said, some resolution, small change in the input, we can get the large output. If it is that small change more than the system. For example, మనం ఉంటాయి కదా sensitive elements. TV is a very sensitive element, right? So for that we have to protect that instrument with the help of a stabilizer, or to prevent from high voltage. I told you hysteresis, right? Tell me examples. Hysteresis, I said to you, I want to that is with the help of engine. So when for example add weight by weight, for example engine number 338, I already explained. I taken the example of engine hysteresis. Here engine, that means I want to determine the performance of an engine. I add 1 kg, 2 kg. I add 1 kg and I got the reading. At 2 kg I got the reading. 3 kg I got the reading, right? So in the reverse order, the 3 kg and 2 kg I cannot get the same readings as that of the initial one. That is due to this internal friction. So this is a loading and this is unloading. Here, for example, for this input, so I got this output. But for this input, I got this output at here. See here, that is the difference. Here, the change in the reverse order, the readings are changed. It should not be the same as that of the initial. Babu, అర్థమైంది బాబు? John Vinay, 338. Right. No, Babu. No, Mr. 329. Impossible to speak in Telugu. Threshold, right. Threshold means here, for some particular input, there is no change in the output. There is no example. What I said to you, the AC, for example, I supplied the voltage, 60 voltage, I increased 80 voltage with the help of the regulator, the AC will not on. So yeah, if the regulator at 240 volts only, the AC starts. That means for the, here I am supplying the voltage to the AC machine. So with the help of the regulator, I increased the voltage 40 volts. There is no response in the AC, and I increased second one, that is 50 voltage again, 100 voltage. There is no response in the AC. If I go for 180 or 200 voltage, then automatically the AC system is responded. That means it is non. That is called threshold with example. That means for if I give input to a system, there is no response in the output. After that input, there will be a change in the output from a system. Now you got the point? Number 48. Number 48. Lateral entry 40. Okay, right, very good. ఎగ్జాంపుల్ అమ్మా, ఇప్పుడు మనం చూడండి వీలైతే నాన్న బాబు, ఇప్పుడు ఫర్ ఎగ్జాంపుల్ మనకి అప్పుడప్పుడు లో వోల్టేజెస్ వస్తాయి. లో వోల్టేజెస్ వచ్చినప్పుడు దట్ బల్బ్ విల్ గ్లోస్ బట్ ద టీవీ విల్ నాట్ ఆన్. దట్ మీన్స్ ఈవెన్ దో ద ఇన్పుట్ ఈస్ దేర్, కెనాట్ గెట్ ద అవుట్పుట్. ఈవెన్ దో సప్లై ఈస్ దేర్, బట్ వీ కెనాట్ గెట్ ద అవుట్పుట్. Oh, correct. So now I want to tell to all the members, you have to compulsory attend classes regularly within the time. You have to maintain. And then already quiz is enabled from 12:30 onwards today by 6 p.m. 4 questions, simple. So whatever that today is we discussed, that only we have to only for that only whatever we discussed in the class, that discussion only I given very simple questions. From 12:30 onwards it is enabled. So I advise it to all the students, we have to attempt the quiz compulsory. And the next another one more. So here already, as all of you known that Jagananna Jivana, that is Divana, Vidya Divana, already the CM is deposited in your mother's account. So I advise you to all of you, better pay the college fee, the first term fee, as early as possible within 1 week or 10 to 15 days. So don't take more than that. So the laptops already CM declared that from the January first week or second week he released it of 2022. Better watch the news, Mr. 313. Okay, 2022 he decided that 7th January 7th date. Maybe sometimes it will prolong. The date should be prolonged. Okay, that should be in the next academic year, not this academic year. That is the Jivana Samiti. I do not know about that. So I advise to all of you, better don't go outside. Stay in home, and that should be safe to you and your total entire your parents or maybe brothers, sisters, right? It should be safe to you. Okay, right? Okay, thank you all of you. Thank you. Maybe the results will be displayed. it will come maybe 10 days, within 10 days. Maybe it will be posted in the website. No need to worry. Number 317 lateral entry, just to watch the website, right? Otherwise, if I got any news about the results, I will post a message in your group. Okay, thank you all of you.